I want to discuss some motion graphs and then show you guys what the motion would actually look like. So I have a velocity time graph here. And what we can see from this velocity time graph is it's not a constant velocity because it's increasing, right? So as the time goes from 0 to 1.4, the velocity goes from somewhere around -2 up to a +2. That's where I'm getting -2 and +2. So it's not a constant velocity. Let's think about what negative velocity means, right? Negative velocity means that it's moving in the negative direction. Positive velocity means that it's moving in the positive direction. And zero velocity means it's standing still. So what we know is it's moving in the negative direction here, then it stands still, and then it moves in the positive direction, which means that it turns around. So let's think about what the position time graph might look like for motion such like this. So here's a position time graph, and I added in that black line. That's the horizontal axis, so that's time. And what we can see is that the position time graph is a curve. And we can see right here, this is where they turned around, and that's right about the same time here. So these are the actual position time graphs and velocity time graphs for the same motion. And it turns around right here. So if I look, that's right around t equals about 0.7. And you guys can't see very well, but that t equals 0.7 is about here. So we can tell that makes sense, right? It was, the position starts at 1, gets almost down to 0, and then goes back to 1. Great. All right. And let's think about what the acceleration would be. So our acceleration time graph, which isn't made for us yet, I'll make it. It's going to look like this. And acceleration is the slope of the velocity time graph. When we look at the velocity time graph, we can see it's pretty much a straight line, and the slope is going to be the same pretty much throughout. And it turns out the slope of the line of best fit of that line is at 3. So my acceleration time graph is just going to be this line here at 3. And that's positive acceleration. So you might think that doesn't really make sense, that the acceleration is positive the whole time and it's the same acceleration the whole time, because I know the object turns around. So how would that look? So let's look at what this actually is. I gotta change. Okay. So I'm going to play for you guys a video of the motion. And you can see it's slowing down and then speeding back up. And I'll show you that down here. I can show you. You can still be able to see the time and the distance. So here it goes. It stops at about 20. This is centimeters. And it goes back to 100, which is 1 meter. So what we might have noticed is that on the way, as the fan cart is going to the left, it's slowing down. As it's going to the right, it's speeding up, which should make sense because we've got this fan blowing to the right. So the acceleration is in the positive direction, which is to the right, which means that when it's going to the left in the negative direction, it slows down. And then when it goes to the right in the positive direction, it speeds up.